And welcome, students. We have been solving systems of equations using the substitution method and the elimination method and by graphing. Now we're going to learn a new method to solve a system using matrices. So first we need to do a little introduction to matrices. We're going to write them in these equations that we're going to work with. We're going to write them in a rectangular array. We're going to call these matrices, or a singular would be a matrix. How we describe a matrix is we're going to talk about the row by column. So you can look at problem A here, and we can see that we have 2 rows and 2 columns. A is a 2 by 2. For matrix B, we can see that we have 3 rows and 2 columns. So this one is a 3 by 2. This is describing the size of the matrix. For question C, we have 3 rows and 1 column. This is a 3 by 1 matrix. For D, we have 1 row and 2 columns. This happens to be a 1 by 2 matrix. Just describing the size of our matrices first. In order to use our matrices, we are going to put this in an augmented kind of system. And this augmented matrix has coefficients and constants, and it's a combination of, here we can see we just have a coefficient matrix, a constant matrix, which would be what the constants are. And the last would be basically what we're going to be looking for. This is what we're going to use to solve our system. If you'll notice, the coefficient matrix just has the coefficients of x, y, and z listed. We will use row operations to transform our matrix into something that we can read the answers off of. So we have these 3 different rules or properties that we can follow. Number 1, we can exchange any 2 rows. Number 2, we can multiply any row by a non-zero constant. That means a positive or a negative number. Just can't multiply it by 0. That kind of wipes it out. And number 3, we can add any row to another row. So let's get started. I'm going to do a few of these for you, or at least 2 of them anyway. So let's see what happens. I'm going to write this in augmented form, so I will need my coefficients. For the x, 1. Coefficient for the y, that's a 1. Coefficient for the z, that's a -1. And then a 2. Here's my first equation. The second equation, a 2 is in front of the x, 3 is in front of the y, and a -1 is for the z, and we have a 7 is what it equals. So let me get it in this augmented form. 3 is the coefficient for x, -2 is the coefficient for y, 1 is the coefficient for z, and then we have a 9. Remember that these must be kept so that this is the x column, this is the y column, this is the z column, and this is your equal to column. If they're not written in order, you will need to do that. Our goal is to make the matrix look like this. The ones along the diagonal and zeros. And what you will have is you'll have, this will be a number, this will be a number here, and you'll have a number here, some number here, here, and here. So my goal is to first, I'm going to get this one, then I'm going to get these 2 zeros. The next thing I will do is I will get this one and make this a 0. My very last thing is I will make this a 1. So this is column 1 is step 1. Column 2, step 2. And column 3 is step 3. And then I'm going to just back substitute to get my answers. So let's play. The very first thing that I need to do is get a 1 in this particular spot. It's already there, so I'm good to go. What I'm going to do next is I'm going to say if I multiply -2 times row 1 and add it to row 2, I'm going to replace row 2 with this. So since I'm going to be doing that, let me just write down rows 1 because that's not changing. And I'll write down row 3 because that's not changing. Be very careful not to make a careless error and copy something down wrong because that will really mess things up. All right, so let's do this out to the side. -2 times row 1. That is a -2, a -2, a +2, and a -4. And then adding it to row 2. Row 2 is a 2, a 3, a -1, and a 7. I'm going to add these two rows. You are a 0, you're a 1, you're a 1, and you are a 3. So this is my new row 2. So I'm going to write this into my row 2. 1, 3. Perfect. The next thing I'm going to do is I'm going to get this guy right here to be a 0. How I'm going to do that is -3 times row 1, and I will add that to row 3, and this will replace row 3. Okay, let's play. I will need to write down -3 times row 1. That's -3, -3, +3, -6. Write down row 3, 3, -2, 1, and a 9. And then I'll add. So I get 0, -5, a 4, and looks like you are a 3. Any mistake in here and it messes up everything. So I need to write down rows 1 and 2 because they don't change. 0, 1, 1, 3. And now write down my new row 3. 4, 3. Okay, what I'm going to need to do next, let's scroll that up just a little bit, is I'm going to need to try to make this guy a 1. He's already a 1. Perfect. So that means I'm going to work on this guy and make him a 0. I could do that by saying 5 times row 2 and then adding that to row 3, and that will replace row 3. All right. These are long and they get messy. Since I'm replacing row 3, I will just write down rows 1 and 2 again. Okay, so let's see, 5 times row 2, that would be 0, 5, 5, ooh, that would be 15. Then writing down row 3 and adding 3 here. Adding would be 0, 0, 9, and 18. So this is going to be my new row 3. The next thing I need to do is make this guy a 1. I can do that by saying row 3 divided by 9, and that will replace my row 3 because I can multiply or divide a row by any non-zero number. So I'm replacing row 3, so I will write down rows 1 and 2 again without changing anything. So let me write down my dotted line here. 0, 0, 9 divided by 9 is 1, 18 divided, okay. This now lets me know, let me write down my x, y, and z, and this is my equal to. This lets me know that 1 times x plus 1 times y plus -1 times z equals 2. And then this next row says no x's, 1y plus z equals 3. And I also have that no x's, no y's, z equals 2. All right, there's one of my answers sitting right there. Almost home. Let's see. I can take this, plug it into there, and get y. So y plus 2 equals 3. Subtract 2 from both sides, and y equals 1. Almost. Now I can take these two answers and substitute into the top equation, and I'll get what x is. All right, needed just a little more room there. So let's do x plus y is 1 minus 2 equals 2. So that is a -1. Adding 1 to both sides tells me that x equals 3. And this is my solution to this system, 3, 1, and 2. Perfect. There's the first one that we've done. And they're long, aren't they? All right, I have your new system. We're going to solve this one, see what we get. Now, I need to write it so that I have my x's and y's on one side. So that bottom equation isn't really in good form. I'm going to add x to both sides. So I've got this guy. He's going to look like this, just what he is. Add x to both sides so that I have x plus y equals -7. And I am going to work with him like this. You have to have your x's and y's on one side. Remember, I write the coefficients 4 minus 3, 28 in my augmented matrix form. Then 1, 1, -7. My first step is to get this guy right here to be a 1. Well, I already have a 1 with that first guy, so I'm just going to swap rows 1 and 2. So 1 and 2, they're just swapping. So I have 1, 1, -7. And then you're still at 4, -3, and 28. Next thing I need to do is make this guy a 0. So I will do, how about -4 times row 1, add it to row 2, and that replaces row 2. All right, that's what I'm going to do. So I have -4, -4, let's see, -4, that would be a +28, I believe. And then I would get 4 minus 3, 28. Add that, get 0, -7, and 56. All right, that's my new row 2. So let's write row 1 again. 1, 1, -7. And I get 0, -7, and a 56. I need to make this guy a 1. So I will say row 2 divided by -7, and that replaces row 2. All right, so let's scoot this up a little, and then we will have 1, 1, -7, 0, -7 divided by -7 is 1. 56 divided by -7 is -8. I now know that if this is x, this is y, and this is my equal to column, that means I have x plus y equals -7, and I have no x's, and y equals -8. So there's one of my answers right there. I'll take that, plug it into that guy, and I will have x plus -8 equals -7. Add 8 to both sides, and x equals 1. My answer would look like 1, -8, where this is my x and that's my y. All right, beautiful. All right, I'd like to do one more problem for you. And in this problem, I chose some where we had some things missing because sometimes these are confusing, but they actually make things easier. because x, y, z equal to column. Let's look at this. The first equation, coefficient in front of the x is a 1, coefficient in front of the y is a 4. There's no z's, and it equals 13. Coefficient in front of the x is a 2. In front of the y, oh, there aren't any. Z is a -5, and equal to is a -3. Last one, no x's. 4y's -3 on front of the z, and then a 9. And now you're ready to solve this guy. He's actually easier than the other one, or some of those other ones anyway. So I've got to get a 1 here. Already, that's nice. I need to put a 0 here. All right, that's going to be a little bit of work. How about -2 times row 1? Add it to row 2, and that'll replace row 2. All right, so I'm replacing row 2, so I might as well go ahead and write rows 1 and 3 down. So there's row 1. Here's row 3. All right, and I'm going to plop row 2 in there as soon as I get that done. -2 times row 1, that's -2, -8, 0, -26. Add it to row 2, that's a 2, a 0, -5, and -3. All right, let's see what we get. 0, -8, -5, and -29. Okay, doesn't look very pretty to me, but got some weird numbers in there, doesn't it? Okay. My next step is I would like to make, I guess I'll make this second one, I guess I'll make you a 1, and that means I'm going to do row 2 divided by -8, and that'll replace row 2. Not pretty at all. I'm getting ready to get some fractions in here. Not happy about that, but not all of my problems can be solved using round, beautiful whole numbers. 1, you are -5 over -8. That's a +5 over 8. Yuck. -29 over, that's a +29 over 8. Okay. Not very pretty. Okay. So I'm just going to write down row 3. Okay. What I need to do next is I need to make you a 0. Okay, so I'm going to do -4 times row 2. Add it to row 3, and I'll replace row 3. Okay. So that means that rows 1 and 2 won't change. So let me write rows 1 and 2 down. 1, 4, 0, 13, 0, 1, 5 over 8, 29 over 8. Okay, let's play. -4 times row 2. That is 0, -4, -20 over 8. -4 times 29. 6, 1, 1, 1 over 8. And it's negative because -4 times that. Okay. Then I'm going to add 0, 4, -3, and 9. I'll do that on my calculator. Man, this was a mess of numbers, wasn't it? Oh, it's always frustrating when they're like this. But it happens. Okay, so this is what I have. I need for this number right here to be a 1. Notice how they're both the same, so I'm going to divide both sides by -11 over 2. And when I do that, I'll get 1s there, so that's going to make that nice. So let me scroll it up just a little bit. Finally, something that's nice on this problem. They're not always messy like this, but sometimes they are. And when they are, you just have to deal with the numbers. And then 29 over 8, that's crazy. 0, 0, 1, 1. Okay, because what I did was I divided this whole row right here. I divided it by negative 11 over 2, so each of those just became a 1. Well, this lets me know that x plus 4y equals 13, and y plus 5/8 z equals 29 over 8, and z equals 1. Well, I have one of my answers, so I'm good there. Next, I'm going to plug this into here and get my y. Y plus 5/8 times 1 equals 29 over 8. I'm going to subtract 5/8 from both sides, and I get y equals 24 over 8. In other words, y is, oops, don't go too far off that way, y is 3. Then I need to get my z. So let's see. Oh, this is nice. My x plus 4 times 3 equals 13, because z didn't matter for that one. X plus 12 equals 13. Oh, subtract 12 from both sides. X equals 1. So my answer for this would be 1, 3, 1. Whew, that was really messy to get to that one, wasn't it? All right. Well, these problems are very long. It's the nature of the problem, so get out a lot of piece of paper because you're not going to be able to solve these in your head. All right, be sure and let me know if you have any questions with them. Just send me an email. Y'all have a wonderful day.